for those of you who are taking the AP exam, so that would be Mr. Ethan, right? Our other two people taking the AP exam are not here again today. So, but we've got, notice that this is f of x, whereas this is f prime of x. You see that? So this is the original function, and by looking at this original function, we're going to say it's increasing when it's on its way up, which I'm going to say is from there to there, or from -6 to -1. It is decreasing when it's on its way down. So I would say from -infinity to -6, union -1 to infinity. Looks like we have a local maximum at -1, +4. And we have a local minimum -6, -3. Evie, you want to be my helper here?
Sure.
You tell me when it changes from concave up to concave down.
I forgot what. No. I forgot what that was.
Oh.
I took so long this time to know what it was.
So, Evie, this would be concave up. This would be concave down. When does it seem to switch from a parabola going up to a parabola going down?
Now. Oh.
So what we say, Evie, is that notice that this tangent line, or the derivative, is, notice how the derivative is starting to pull its way up.
Yeah.
And then finally when it gets to this spot, then it starts to pull itself back down.
Okay, I just
See what I'm saying?
that was.
Yep, that's all right. So that would happen at a coordinate of about -4, 0. That would be your point of inflection.
Well, then what is concave up and concave down?
So if you notice here, concave up is going to be in that section, so from -infinity to -4, and
Oh.
then concave down from -4 to infinity. Okay.
So your concave is just in between your local max and local min?
Yeah, well,
Because wouldn't it also hit like at -8? Or what? Like, because that goes over 0 too.
okay. So let's ask that question again after we do this one, because I think your question is going to be answered with this next one.
Okay.
Okay, Emily's question is really going around this piece of, notice that this was your original function. This is f prime. I'm giving you the same graph, but we're now going to call this a derivative as opposed to the original function. That's going to change the way that we answer these questions. Increasing is when f prime is positive. Notice this is the derivative. It's positive wherever it's above the x-axis. So I'm not going to write from -6 to -1, okay? I'm going to write from
-6. No, -infinity.
-infinity to -8.
That's funny because it's just like the infinity sign flipped.
Yep, exactly.
Wow. That's stupid.
No,
You're wrong.
I think the same thing when I write that one all the time too. I like that you notice that. Union -4 to +2.
Why is it positive? Oh, because it's equal.
It's going to be decreasing wherever f prime is negative, or wherever the graph sits below the x-axis. And it sits below the x-axis from -8 to -4, union 2 to infinity. Talk with the person next to you. How do you, again, determine the local max and local min, and are there any on this graph? Take 30 seconds, talk, go.
I still have
So that's now a question, because they haven't gotten approval, so you can have the liquor store yet, so.
Yeah, I'd be like.
Oh,
Oh, yeah, this is it.
It could
Well,
just
that
be a
was still
building,
the
it
same
could be
Yeah.
like stuff to get approval.
I thought it was gonna be a warehouse.
No.
Like it just.
No, the one that took the.
So are there two? I don't know which one's the.
Yeah.
Okay, local max happens where f prime changes from positive to negative, and f prime changes from positive to negative at x equals -8. F prime also changes from positive to negative at 2. Please notice in this scenario, okay, that we can't identify what the y value is because we don't have the original function. We don't know the height of our true local maximum. All we know is it occurs at -8 and at +2. The local min occurs where it changes from negative to positive, and the derivative changes from negative to positive at -4. Again, there's nothing else that we can say about its location other than at the x value. Concavity. If this is f prime, then f double prime can be expressed by the tangent line. The slope of this tangent line is negative, so therefore the original graph is concave down. Here, the slope of the tangent line is positive, so it will be concave up. Here, the slope of the tangent line is negative, so it will be concave down. Notice as we look at this graph that it's when I draw the red that it will be concave down because all the tangent lines will have a negative slope, and at the blue is where it will be concave up because that's where the tangent lines will have a positive slope. So concave up will be from
-6 to
Oh,
-1.
never mind.
That's okay. -infinity to -6, and then -1 to infinity is going to be our concavity down. Inflection is where it changes concavity, and it changes concavity here at -6 and here at -1. So Emily, your question earlier about this, again, this would be a local max if it was f prime, but it's not f prime. So the local max actually happens where it looks like there's a local maximum. Whereas here, this is f prime. So therefore, the local max happens when the derivative changes from positive to negative, which would be right at that spot.
Because that has like the steepest like slope, so it'd be like the highest derivative, or like what? I'm not picking up what you're putting down.
So as we consider the original function, just if we were to just forget derivatives or anything at all,
Yeah.
do you agree that this is where the derivative is equal to 0?
Yeah.
And the derivative changes from positive to negative.
Yeah.
Okay? That's for the original function.
Okay.
But this is the derivative. So we're trying to figure out information about its original function.
Mm-hmm.
So that's where the derivative changes from positive to negative. This changes from being above the x-axis to being below the x-axis. So that's why at this spot, that's why we have a local max.
Okay.
So that's why the inflection on the derivative is, there's two different ones and it's not a point?
Yes.
Okay.
Nope. I want you to take that information and see if you can do this one on your own. Okay?
So that's the derivative?
Yep, I'm giving you f prime. Everybody okay with the first two sets there?
Yes.
Okay. And concavity, I'm going to say that it is going to be concave down from negative infinity to negative 7. And from negative 3 to positive 4. It will be concave up from negative 7 to negative 3. And from 4 to infinity. And so concavity changes at the inflection points of x equals negative 7, negative 3, and positive 4. I put some dots there. I don't know if this would help people or hurt people, but the original function might look something like this. No, it wouldn't. My bad. I messed up right here. This point should be over here. That's what I wanted. So anyway, all right, what's different about the last one?
It doesn't have no point.
Double prime.
What do you mean it doesn't have no point?
There's no like circle at the very top where it switches.
Oh, I got you. I got you.
That's really helpful for me.
Okay, I understand. It turns out that we don't really need to know how high this goes. Brecken is correct that what's most important about this is f double prime. F double prime does not tell us about increasing or decreasing.
Oh.
F double prime does not tell us about a local max or a local min. F double prime only tells us about concavity and inflection. And the rule is f double prime is going to be positive when it's concave up, and f double prime is going to be negative when it's concave down. So by looking at this piece, if this is f double prime, I'm going to be concave down from negative infinity to negative 3, union 6 to infinity. And I'll be concave up from negative 3 to 6.
We have to memorize like all this?
The inflection occurs whenever your concavity changes, or whenever the second derivative changes sign. And that's going to be at x is equal to negative 3, and at x is equal to 6.
Cool. I love double prime.
Okay.
Double prime is our favorite.
I want you to flip that over then, and we're going to, whoops, not that one, Mr. Gintz.
Oh, no.
So
What's for next week?
I want you guys to try a couple of these problems. These are actually pulled straight from AP practice material. Every, like, say, 5, 6, 7, 8 years, the AP releases its multiple choice questions. This one would be from 2012. It's problem number 80. You're allowed to use a calculator. Only half the problems you get to use a calculator, half you don't. For Ethan, who's taking the exam, just to let you know, so you guys can, kind of, prep yourselves. But if you get a 45% on the test, that scores you a 3. That's a passing grade. So that's how hard the test is. So I've had students before here who have had the highest GPA in their class, and they got a 1 on the AP exam. Okay, it's not easy. 55% would give you a 4, and a 65% approximately would give you a 5. And so to avoid a 2, usually if you get about a 33%, usually that would be a 2. Anything less would be a 1. Okay, so it can be challenging. What I want you guys to do is I want to try to do 2 problems before you head off to lunch. Then we'll do 1 when you get back.
I know. That's
But I'd like you to look at this one right here, okay? You can talk to the person next to you, take about 1 minute and 15 seconds, and try problem 85. Says the graph of f prime is given. Go ahead.
Wait, where's supposed to be?
Isn't it going from positive to negative?
Yep, do problem 85, not 80.
I have delivery for Sophie.
Hey, is the Chick-fil-A truck here?
Yeah. The lines take a long time, so get there fast.
Okay, 5, 4, 3, 2, 1. Let's check it out. It says find a local maximum. Local maximum occurs when f prime changes from positive to negative. Positive to negative, it occurs right here, so the answer is letter C. 1.
Because it goes from positive to.
Locked in.
Yes.
I'm going to give you 2 minutes. Try the problem above it. Try problem 80. Go. Take about 2 minutes. Try problem 80.
So why is that? Oh, I thought C was 3. What question did you say to do?
The one right above it.
Is it supposed to end at 4, or is it supposed to be an arrow that like keeps going?
It ends.
Gotcha.
Oh.
Relative is the same as local.
Local is the same as relative. Yep. Give you another 40 seconds to make a guess.
No,
Gotta have a good Chick-fil-A truck.
Oh,
every once
yes.
in a while.
I had Chick-fil-A lately.
Can we take a class trip to Chick-fil-A and just like have an outdoor lesson while we eat?
It's literally just work time after this, isn't it?
Realistically, though.
Oh, yeah, one more problem.
So then, like,
So let's bring it
basically
back
it's
here.
fine.
5, 4, 3, 2, 1. Okay, relative minimum. That's where f prime changes from negative to positive.
Yeah.
And it does change from negative to positive, so this one would be correct. If this was just f, then it looks like it would have an inflection point. It would change from concave down to concave up at -2. But this is f prime. And so therefore, there's not an inflection point there. In fact, if there was an inflection point, it would be here, where the second derivative changes from concave up to concave down. So the inflection point is not at -2. The definition for concave down is going to be where f double prime is negative. And if you look, if this is f prime, f double prime will be represented by the slope of the tangent lines. You can see that anywhere you draw them over here, they all have a negative slope. So 0 to 4 is correct. So this is 1 and 3. So it's letter E.
See, yeah, there's only said one only. Because I got confused since the stuff wasn't.
You guys can head off to lunch. We'll come back and do one more together. I'm sorry, 2 more together.
You're-
Then you can go time.